In this lesson, we'll review a math problem from the grid-in section. We're on page 598, question 18, the final problem. We know this is a difficult question. We have these 5 cards, and I've attempted to depict them here. And here's the call of the question. If the 5 cards above are placed in a row so that this shaded one, and I put a different color here, is never at either end, how many different arrangements are possible? So this is really a difficult permutation. It's an order question, and I'll show you 2 ways to solve this one. One way is we can make a dash for each one of the cards and think about each blank, each dash represents the maximum number. And this is a kind of a tough problem, and I'll show you really the shortcut here. You should recognize this shaded card can't be at either end, so you really should think about doing the ends first. So always remember, step 1 is the maximum number of possibilities. Step 2 is multiplying them, and that's how you can do any type of combination or permutation problem. So here, the maximum number of choices is 4 because we can't have this shaded. And then think about going down to this end. Once you've selected a card, how many are left? There are 3. Now we can focus on the ones in the middle. And now you should recognize it's not 2 here. It goes back to 3 because we gained the shaded card. So here it's going to be 3. Then we subtract 1, it's 2, and then 1, and then you can simply multiply. So here, this is 3 times 2 times 1, and that is 6, and 6 times 12, and that's it. The answer is 72. But that's a little tougher. I think not everyone can recognize that doing the ends first helps. Another way, a little bit longer, I can show you how to address this problem is, all right, let's think about the different possibilities, especially if you have a little bit more time. So we'll start with the 3 dashes again. Well, actually 5. And well, let's think about, we know the shaded card. Let's say the shaded card is here. All right, this is, and we know it can't be at the end, so this is 1 part. So how many do we have left? All right, so now we have 4 times 3 times 2 times 1, and we multiply 4 times 6. We know that's 24. All right, that's just one of the 3 spaces for that shaded card. Now we're going to switch the shaded card over here. Oops. And we have 4 times 3 times 2 times 1. You should recognize it's going to be 24 each time. And then there's one more if we put the shaded card here. All right, these are the only 3 spots the shaded card can be. And then we have 4 times 3 times 2 times 1, and that's 24. You don't even have to multiply after you do it the first time because they're all 24, and you simply add these up. These are each one a different possibility with the card in a different one of the 3 slots, and you still get the 72. So there's really 2 ways to do it. This is a sort of a little bit longer, sort of a manual way, but if you have time, you can do it. And this is more the more reasoning, intuitive based problem. Hopefully, in either case, though, you'll arrive at the correct choice, 72. All right, see you next time. Thanks for watching.